So remember how I told you at the beginning of the unit that all the formulas that we've learned so far are going to come into play and are going to need to remember them? That's this one. So this is a very useful little chart for you to know. So my suggestion is that you highlight it, put a little sticky note there, do something so that you note that this is important. I'm just going to highlight this part right now. Formulas in the coordinate plane. So we're going to kind of read through these, and this is useful because it tells you what the formula is, and then it tells you how we're going to use it. So what I want you guys to do is kind of read through it right now with your partner and do a little annotating. So underline some of the important key words in here and kind of talk with your partner how we are going to use these formulas and when to use them and why they're important. All right, guys, let's talk about distance formula. Remember, if you cannot remember the distance formula, you can derive it using which favorite theorem? Pythagorean theorem. Yep, that's the only theorem you know. Rose, when would distance formula come in handy? To show that two sides or two what? Diagonals are congruent. Congruent means what, Lily? Singer. Lily Singer. Yeah. What does congruent mean?
They're like the same.
The same. Okay. So let's say, for example, I ask you to prove, because what we're going to do is I'm going to give you a shape on the coordinate plane, and then I'm going to ask you to name it using the most precise name, and your math work is going to be the proof that it is that name. So for example, say I give you a triangle. Oops, that's not a very good triangle, and I tell you it's equilateral. Equilateral means all sides are equal, and I want you to prove it. Any ideas of what you might have to do? The distance formula. So Jen says do the distance formula on which side? All of them, and they should all come out to the same length. And that proves that that's an equilateral triangle. Does that make sense? Okay. We're also going to use midpoint formula. Malika, when does midpoint formula come in handy? To determine the coordinates of the midpoint, and to determine the midpoint cuts it in half, and what do we call when we cut something in half? Bisect it. So to determine if two diagonals bisect each other. Okay, so that might come into handy if I'm doing like a rhombus. I just did a rhombus. Pretend those lines touch. Okay. The whole point of a rhombus is that the diagonals bisect each other. So we could use the midpoint formula to determine if a shape is a rhombus by looking at the diagonals and if they bisect each other. Okay. The last one that we are going to use that is going to come in very handy is the slope formula. Karina, when would I use the slope formula? Parallel. What else? To check if something's perpendicular or if sides are perpendicular. So, parallel lines have what type of slope? The same. So if I ask you to prove that this is a parallelogram, what could you do? Find the slope, and you should get two sets of the same. Perpendicular. Guys, what shapes have perpendicular corners in them? Squares and rectangles. So I could ask you to determine that this shape is a square. And there would actually be two steps to this. First, we would need to determine that all sides are what? The same or congruent using the distance formula. But a rhombus also has congruent sides. So what else would we have to do to determine that this is a square? That it has right angles. So you'd have to find the slope of all of the lines. and they should be opposite and what? For perpendicular. You guys remember? Reciprocal. So opposite, reciprocal. Let's write that underneath. Okay, so just as a reminder, opposite reciprocal means it's a different sign, and you flip the fraction. So if I have a slope of 1/3, the opposite reciprocal to that would be negative 3 over 1. Okay? This is tough. This kind of takes, it's a lot. It is kind of, when you think about math in terms of like what you guys are going to do in high school and college, this is the closest to what I can explain to you. So a lot of math ends up being, I give you this statement, now I want you to use all your math knowledge to prove it. Okay? So we're going to do practice number 1 because it has the graph on it. Both of these give you a triangle, and you have to determine if the triangle is scalene, isosceles, or equilateral. So let's review these terms really quick. Equilateral, we should all know. Equa means the same. So an equilateral triangle, all 3 sides are the same. Isosceles is the next one that comes up a lot. Rose, what's the isosceles triangle?
Isosceles is when 2 of the angles are the same while the third one is different.
2 of the angles are the same. This one is different. Anything else about an isosceles triangle, Lily?
The 2 sides are equal, but they're longer than the bottom side.
Yep, the 2 sides are congruent, and the way that it always works out is that they should be longer than that other side. So that's isosceles. So equilateral, let me draw an equilateral. Close enough. All angles are equal and all sides are equal. So then, does anybody remember what scalene is? Jen?
It's when none of the sides or angles are the same.
None of the sides or angles are the same. So something like that. It does look pretty isosceles. Let me try again.
Just do a right triangle.
There. It's not, let's just pretend. A right triangle?
Yeah.
You guys, we're focusing way too much time on. A right triangle could also be isosceles, though.
Just do a right triangle with the...
There. Okay. But I just want you to know, scalene are not always right triangles. Lily?
Doesn't scalene also have to have an acute and an obtuse angle?
Yes. So, no, not necessarily.
They could have a right angle.
No, because that makes it a right triangle. She's right. A scalene has an obtuse. Here we go. Whatever. You guys get the idea. All the angles are different and all the sides are different. Okay? So that's a scalene. So, it seems to me like what we're going to have to do for all of these is first find the length of all the different sides. So, we're going to have to do the distance formula. Before we even start, hold on. Before we even start, let's write down the coordinates of each of the points. So A is at -2, +3. Okay, so -2, +3. B is at 2, 2. Jen, I'm purposely ignoring you. Okay. And C is at -2, -1. Okay, Jen, what's your question? So she said if it's already drawn out for you, couldn't you just count the sides? For AC, could you do that? Yes. For CB, could you do that? No, you can't, because it's going diagonal. So here's what I'm going to allow you all to do. Because AC is just going straight along the units, I will let you just count them, but you still have to write out what it is. So what is the length of AC? 4? Daniel got 4? Okay, there's one done. So let's do BC. We're going to have to do distance formula. So big old square root, guys. And what I want you all to do is please make sure that I can read your work and that your work goes with the problem. So as I was grading your homework over the weekend, that you turned into me on Friday. A lot of you are showing your work, but you're showing it as scratch work, and it's not even next to the problem that it goes with. So I have no idea what it is you're doing. And when you say that BC is 5, I don't know how you got that because I cannot read your work to save your life. So you need to make sure that you are showing your work step by step. So let's find the difference between the x's. What is the x coordinate of B? 2. Minus the negative, so that makes it plus what? 2 squared. Plus. Difference in the y's. Y coordinate of B? Minus negative 1, so that makes it plus 1 squared. I hope you guys are not writing as large as I am. So 2 plus 2 is 4 squared plus 3 squared. 4 squared is 16 and 3 squared is 9. Oh, you guys, look at this. I'm like psychic. BC is 5. Everybody say, oh. Ah. Okay. Because I said, I just guessed it.
Wait, what do you mean?
Square root. Okay, so for A, B, I'm getting a lot of people that said you got square root of 17, which should be 4.12. Okay, so AC is 4, AB is 4.12, and BC is 5. So what type of triangle is this? Scalene. Okay, so we can say that this is a scalene triangle. Here, let's write that. Triangle ABC is scalene. Okay, and you showed all your work because you showed me the distance formula for all of the sides. Does that make sense? Not too bad? I know. So for number 3, it gives you vertices, and it tells you show that the parallelogram. So, do you have to prove that it's a parallelogram? No, it already tells us. So we can assume that it's a parallelogram because it tells you it is. What does it want us to prove? That it's a rhombus. Okay, so how would we do that? A rhombus is a parallelogram, but what's special about it?
2 sets of parallel.
Well, that's all parallelograms. It has to do with the side lengths. All sides are equal, okay? So a rhombus is a special type of parallelogram where all sides are equal. So what would we have to prove here? Does slope help us with length, though? No. Slope would help us to prove that it's a parallelogram. Jonah? Well, you'd have to do distance formula again. So just write the note, distance formula. Guess what? Distance formula is going to be your new best friend. And if you didn't have it memorized for the last unit, you will definitely have it memorized for this one. So you want to prove all sides equal. And what we're going to do, I was going to do this tomorrow, but we might actually just do it today because it'll probably help you on your homework. I'm going to give you guys, we're going to create like a little folding thing, and we'll probably start it today for all of the shapes and their formulas. But today I'll have you guys start so that we can get all of the different specifications of each shape. Does that make sense? So that a rhombus has parallel lines, but they're all equal, that kind of thing. So a rhombus has all equal sides. So it tells us in the problem that it's a parallelogram, so we don't have to prove that. What we do have to prove is that it's a rhombus by finding the length of all sides. Okay? So is everybody okay if I skip it? Okay, sure. So let's go to the next page. So number 5 is a little bit trickier because it's going to tell us not much. So what it tells us that it's a quadrilateral, and we're going to need to figure out what the most precise definition of this quadrilateral is. And it kind of gives us a hint. So it says by connecting the consecutive midpoints of each figure. So consecutive midpoints means the midpoint of here and here, and the midpoint here and here. But I don't really like that. I'm not going to do it the way the book wants us to do it. So you guys ready? It says to do the midpoints, but I don't like it. So when it asks us something like the most precise classification, that means that we're going to be looking at angles and we're going to be looking at side length. The first thing that I would suggest, and we probably want to look at slopes. We're probably going to do a whole bunch of stuff on these. My initial thought, what is your initial thought? What type of quadrilateral would this be? A rectangle. Now, a rectangle means that we have all right angles, correct? Can you think of... So the question wants us to form the consecutive midpoints of each figure. Consecutive means right after each other. So all I did was I labeled the midpoint of each one, and then we connect them. What shape does this look like? A rhombus. How would we prove that it's a rhombus? All sides are equal. So the first thing we would have to prove is that all sides are equal. Now, a rhombus is also a parallelogram, right? Did it tell us that this was a parallelogram? So can we assume that? So after we prove all sides are equal, what then would we have to prove? That these sides are parallel and that these sides are parallel by finding the slope. So that's what you would have to do. You'd have to show all the sides are equal by doing the distance formula, and then you would have to show that these two lines are parallel and these two lines are parallel, and you cannot just assume it because they look parallel. Okay, we're not going to do it.